Good evening, everyone. Today we're going to continue with partial fractions remaining questions, though we have very less number of questions to do in 7.5 for today. And after this, we will start integration by parts. So, the questions that are left over are question number 16, question number 19, 20, 21, 22, and 23. Question number 16. 1 by x into x power n plus 1. There's a hint given in the book. Just follow the hint and try to apply the same hint for all kind of questions of this time. 1 by x into x power n plus 1. So whenever you find a sum of this nature, multiply and divide with x power n minus 1. Multiply the numerator and denominator by x power n minus 1. Say tomorrow if you find a question which is like 1 by x into x power 5 plus 1, then we multiply the numerator as well as the denominator by x power 4. Okay, the reason, because when you take x power 5 as t, the differentiation of x power 5 will give us 5x power 4. So that will get cancelled eventually when you follow substitution method. And later on you have to break the sum using partial fractions and then integrate them. So question number 16. So what? 1 by x into x power n plus 1, as instructed in the question or as instructed in the hint, multiplied the numerator and denominator with x power n minus 1. Through this, we come to this step, because when the base is same, power is added for these two terms. So x power 1 and x power n minus 1 will give you x power n. Now take t as x power n. When t is x power n, differentiation of x power n is n x power n minus 1. So dt by dx will be n x power n minus 1. So using substitution method, we will change the question to this form. And then what? Take this separately, partialize it, find the value of a and b. Once you find a and b, integrate in terms of t itself, and last substitute what you've assumed as t. You'll get the answer for 16th one. 20th sum, 1 by x into x power 4 minus 1. Similar, just like the 16, the only difference is there plus 1 and here it is minus 1. Multiply and divide with x cube. So you come to this step, take t as x power 4. dt by dx, differentiation of x power 4, will give you 4x cube. So eventually that will get cancelled. You will get this way. Now partial fractions. After that you find a and b and then integrate in terms of t. Substitute t function later. Question number 19. This question we cannot follow that type, but then this is if you don't follow substitution in the beginning, this 2x will not be removed. So you'll find it hard to partialize. So it is better we follow substitution in the beginning, because if you take t as x square, the differentiation of x square is 2x. So this 2x will get cancelled and the sum will transform to this form. Then partialize it, find the value of a and b and then integrate in terms of t. Later substitute the t value. 21st question, integration of 1 by e power x minus 1. The hint given in the book is take t as e power x. It doesn't matter whether you take t as e power x or e power x minus 1. So both ways you will come to a point where you can integrate them easily. So I am taking t as e power x minus 1. So differentiation of that will give me dt by dx is equal to e power x. So dt by e power x equals to dx. So dx becomes dt by e power x. And this is 1 by t. Now the main thing to be noted when you use substitution method is the sum should be entirely transformed into the t form, which is not happening here. The problem is this e power x, but do we have anything to replace that in terms of t? Yes, t equal to e power x minus 1. So t plus 1 is e power x. So let's change this e power x as t plus 1. In that case, the sum will completely turn in terms of t. Now partialize, find the values of a and b, insert them back, integrate it, substitute t back into the answer. So then the next exercise is integration by parts. Integration of functions that are in product form. But make sure that the functions are different. They are not of same nature. So when we use integration by parts, the functions that are in product form must be a different function. Say, trigonometry with an exponent, algebra with a logarithm, something like that. Only then we use integration by parts, or otherwise called as ILATE method. ILATE, ILATE. I stands for inverse trigonometry. L stands for logarithmic functions. A stands for algebraic functions. T stands for trigonometric function. E stands for exponent functions. The formula here is integration of u dv. Integration of u dv is uv minus integration of v du. Now, this is the first sum of the exercise. Integration of x sin x dx. Now, as you can see, it is in product form here, and there are two different functions. Now, what are the functions? The first one is an algebra, the second one is a trigonometry. So, I wrote A and T under that. Now, as per the order, as per ILATE order, A comes first and then T. As per the ILATE order, A comes and then only T comes. So, whatever coming first will be considered as U. So I'm going to consider u as x. So then dv will be sin x dx. U is equal to x, dv equals to sin x dx. From u, you have to find du. So we have to differentiate this. From dv, we have to find v. So there from dv, we need to find v. So we have to integrate this. So using u, you find du by differentiation. Using dv, you find v by integration. So that's what I've done here. U equal to x, du by dx equals to 1. Du equals to dx. dv equals to sin x dx. So v equals to integration of v equals to minus cos x. Then applied in the formula u dv, integration of u dv equals uv minus integration of v du. U is x, dv is sin x dx. Using u we found du, and using dv we find v. Put it in the formula in the respective places. You still have to integrate this term, integrate that, with that the sum is over. Third question, integration of x square into e power x into dx. So x square is algebra, e power x is exponent. As per ILATE order, ILATE, A comes first and then only E. So therefore, U will be x square and dv will be e power x into dx. Using u, you need to find du. So differentiate it. Du by dx is equal to 2x. Du equals to 2x into dx. Integration of dv is integration of e power x dx. So we get v as e power x. So u, through this we found du, and then dv we found v. Now put this back. What is the formula? U dv equals uv minus integration of v du. So integration of x square into e power x dx equals u into v, that is x square into e power x minus v, which is e power x into du, which is 2x dx. So x square into e power x minus 2 outside, x into e power x into dx. So you find this in product form again. X into e power x is again in product form. So once again we have to use integration by parts here. But not here. I'm going to take this separately, deal this with, get the answer and then substitute it over here. So I'm going to consider integration of x into e power x as I. So this one is I along with the integration sign. So I1 equals integration of x into e power x dx. Again, algebra and exponent. So u equals to x, dv equals to e power x into dx. So du equals to dx here and v equals to e power x. So integration of x into e power x dx will be uv, which is x into e power x, integration of v du, which is e power x into dx. So x into e power x minus e power x plus c. So this is the answer of I1. Substitute it back. Then the answer is x square into e power x minus 2 times x into e power x minus e power x plus c. So which means x square into e power x minus 2x e power x plus 2 e power x plus minus 2c. And let's consider minus 2c as capital C. So this will be x square into e power x minus 2x into e power x plus 2 e power x plus c. So let's go to algebra and logarithmic combination. Question number 4, 5, 6 are that type, and I'm going to do the 6th one. Based on that, you can try 4 and 5. 6th question, integration of x square log x. Integration of x square log x, where x square is algebra, log x is logarithmic term. So as per late order, L comes first and then only D. So therefore, log x is considered as U, x square is considered as D. Using U, you find du, which is du dx by x. Using dv, by integrating, we find d, which is x cubed by 3. Then we applied in the formula integration of u dv is uv minus integration of v du. So that will help you to come to this step. X cube and x get cancelled. Remaining is only x square, and integration of x square is x cube by 3. X square integration is x cube by 3. That's it. There is no other term to integrate. We are done with this. So this way we can do the previous two sums also. This is question number 6. So 4 and 5 is also similar to this one. So before we take up the next few sums, which is in the form of inverse function, we need to learn these 3 formulas. This comes as part of the next exercise, but without this we cannot solve those questions. So this is some added special inverted forms. So take this into account, memorize it, and then start the sums. Question number 9, integrating x cos inverse x dx. Now, x is an algebraic function, cos x is an inverse trigonometric function. So as per late order, I comes and then a. So cos inverse x will be considered as u and dv will be x dx. Differentiation of cos inverse x is minus 1 by root over 1 minus x square. Integration of x is x square by 2. Put it in the formula to come to this step. Now here you will find that it is in the form of integration of x square by root over 1 minus x square. Now what I'm going to do here is I'm going to add plus 1 and minus 1 to the numerator so that I can split the denominator. So adding plus 1 and minus 1 to the numerator, separating the term according to the denominator. So I'm grouping x square minus 1 divided by the denominator plus 1 by the denominator. So x square minus 1 by the denominator plus 1 by the denominator. Now this is x square minus 1, this is 1 minus x square. So I took a minus out and made it into 1 minus x square. Now 1 minus x square gets cancelled with root over 1 minus x square. What remains is root over 1 minus x square. And this will come as it is down. This half is in multiplication for both the terms. So when you open the bracket, make sure that you don't miss this out. Now when we need to integrate this, we take the help of this formula which I just now shown you. And then when you integrate this, we take the help of the special integral formula that we learned previously, which is this. So integration of this will be based on this. Integration of this will be based on this. So that's it. We get the result. And then just simplify. Try to get it in the, re-simplified form. Question number 10. Integration of sine inverse x the whole square dx. So here the question is not combination of any two functions but just one function. So let's use substitution and come out from this one. Take t as sine inverse x. If t is sine inverse x, dt by dx is 1 by root over 1 minus x square. So root over 1 minus x square into dt equals to dx. Usually when we follow substitution method, we want to change the entire question in terms of t. And it doesn't happen here if you retain it this way. Isn't it? Dx becomes dt into root over 1 minus x square. So now just check for some x term which can change the question in terms of t. Since we took t is equal to sine inverse x, sine t equals to x. So here in the place of x, substitute sine t. This will be sine square t then. 1 minus sine square t is cos square t and root over cos square t is cos t. So cos t into dt equals to dx. Now put it back in the question. Since this is t, this becomes t square. dx becomes cos t into dt. Now it's combination of two functions, algebra and trigonometry. Algebra a comes first and then t as per Euler order. So taking u as tx square, t square and dv as cos t dt. Differentiate t square to get 2t dt. Differentiate dv to get v as sin t. Put it in the formula. We still need to integrate t sin t. So I am considering that as I1. I1 is integration of t sin t. Once again paths u is t, dv as sin t dt. Apply, you'll get this as the answer. Once you find what is I1 is, substitute it back here. So last you get the answer like this. And in the end we have to substitute t. So I substituted wherever there is t. Since t is sine inverse x, when you have a sine function outside, sine of sine inverse x will be x. So t square becomes sine inverse x the whole square. Sin t becomes sine of sine inverse x because t is sine inverse x. Sine of sine inverse x is x. 2t cos t will be 2 sine inverse x into cos of sine inverse x. And 2 sin t will be 2 of sine inverse x. So wherever sine of sine inverse x comes, we put x over there. Now cos of sine inverse x becomes 1 minus x square. That's because we assume we assume sine inverse x is equal to a. So sine a will be x by 1, which is opposite side by hypotenuse side. So adjacent will be root over 1 minus x square. So cos a will be root over 1 minus x square by 1. So I change this sine inverse x to cos over 1 minus x square. So cos and cos inverse get cancelled, so we have 1 minus x square. This way we get the answer for this question. Question number 11. Integrate x cos inverse x by root over 1 minus x square. Since t is cos inverse x, dt by dx will be minus 1 by root over 1 minus x. So minus root over 1 minus x square into dt equals to dx. Usually we substitute t, but here there is no need of this. Because since we have a root over 1 minus x square in the question, this will get cancelled with this. So aiming that, I am not substituting x here. So I am directly substituting dx as minus root over 1 minus x square into dt. So I come to this step. So this and this get cancelled. Minus stays out because of this minus. It will be integration of cos t into dt. Cos t is because x is there and x will make it into cos t. Now perfect substitution, like we changed the whole question in terms of t. Now use parts to integrate this. Algebra, t is algebra, cos t is trigonometry. A comes first and then t, so u is t and dv is cos t dt. Question number 30. Tan inverse x dx. Take t as tan inverse x. Dt by dx is 1 by 1 plus x square. So 1 plus x square into dt equals to dx, cross multiply. Now what is, if t is tan inverse x, x is equal to tan t. So in the place of x I am substituting tan t. So x square becomes tan square t. 1 plus tan square t is secant square t. The whole question will come to this form now. Again algebra and trigonometry. So hereafter, from here on, you have to do the parts to get the answer. Once I am done with this, the rest will be covered in the next video. Thank you.